Okay, BC students, this is for you. This is basically integration by parts, right? You see that there's like a product going on here, so please do not, right? So do not just say, oh, x to the third over 3 times sine x plus c. Like that's completely illegal, because like obviously the derivative of this is not that, right? So this requires some other technique, right? It's a product. We need like a reverse product rule for anti-differentiation, right? And so what it is it's integration by parts, right? So if I'm trying to integrate something like this, then the rule we get is u times, let me do this in some color, u times v minus the integral of v u prime with respect to x, right? So the idea is you need to define a u and you need to define a v, and then you need to find, put them into this formula and do what it says, right? General guidelines are your u should be the thing that if you take the derivative of it enough, you will get 0, right? So there's two options for u, right? It could be x squared or cosine. So think about it. If I take the derivative of cosine a bunch, do I ever get 0? No, right? It's going to go cosine sine with some negatives in there. But if I take the derivative of x squared enough, I will get 0. So that's what I want to make my u, is that x squared, because it will eventually give me 0. And then I'm going to define the other piece as v prime. Okay, we're going to take the derivative of u, right? We're going to find du, or u prime. In this case is 2x. And we're going to integrate v prime, right? So if I integrate v prime, I get sine x. And then we put it in this formula, right? So this is u v prime. If I integrate that, I get u times v, right? So that's x squared times sine x minus the integral of v, which is again sine x, u prime, which is 2x, and we're integrating that with respect to x. And what you maybe notice at this point is that we have yet another problem. I still cannot integrate this, right? It's still not in a form I can integrate. So I need to go through that process again, right? And I need to say, well, I'm going to let this be u. I'm going to let this v be v prime. So u is 2x. U prime, therefore, is 2. V prime is sine x. Therefore, v is negative cosine x. And this becomes, over here we still have x squared sine x. It's going to be minus whatever we get here, right? And so we're back to this formula here, u times v minus integral of v u prime. So we have u times v, 2x times negative, different color, times negative cosine x, and then minus the integral of v prime of v u prime. I have prime on the wrong thing up here, v u prime. So that's the integral of negative cosine x times 2, and we're integrating with respect to x. And now hopefully you can see that we can integrate this because the 2 and the negative are just constants. And so if we do integrate it, we're going to get negative, the integral of negative cosine is just sine. Let's use these for that. And then we have this big bracket because our signs are going to get us a little confused here. So let's go from over here. This is going to be x squared sine x. Let's keep this big minus there. 2x times negative cosine x is going to be negative 2x cosine x. And then, this is that minus sine, and this is that minus sine. So let's clean this up. These two minus signs are going to take it and become a big plus. And then we're going to distribute that negative in there. And we're going to get x squared sine x minus plus, right? Negative, negative, plus 2x cosine x. And this is going to be minus 2 sine x, right? Because this negative distributes there, it makes it negative again. And plus c. All right, so that's that. At the end of this video, I'll show you the way that Jaime Escalante does it. I showed you guys in class once, but it's it's pretty cool to see. It's a little bit easier, especially if you have to do this like multiple times. So I'll show you that in a second. Let's do this other example real quick. Again, we want to choose our u to be the thing that when you take the derivative of it, you can eventually get to 0. And you want your v to be the other thing. Sorry, your v prime to be the other thing. So in this case, u is going to be x, and v prime is going to be e to the 4x. Du is therefore 1. And the integral of v prime, which is v, is e to the 4x divided by 4. Okay, so this is going to equal u times v, x, e to the 4x over 4 minus the integral of v, which is e to the 4x over 4 times du, which is 1, and we're integrating with respect to x. So this turns into x e to the 4x over 4, right? That's just that piece. Minus the integral of e to the 4x again is e to the 4x over 4. There was already a 4 there. That's going to turn into 16 plus c, and that's sufficient for that one, right? Like you don't need to find like terms or anything like that. Okay, so let's figure out this Jaime Escalante tabular method, right? So basically what it is you're going to draw a 3-column table. You're going to put your u, or the thing you're going to take the derivative of, over here. You're going to put your v prime, or the thing you're going to integrate, here. And over here, we're just going to keep track of some signs. Okay, so like in this example up here, this was x squared, and this one was sine x. Right? No, cosine x, sorry. This one was cosine x. Okay, and we're just going to go ahead and take the derivative down on the u part as much as we can. Right? So derivative of x squared is 2x. Derivative of 2x is 2, and the derivative of 2 is 0. So we stop when we get 0, right? And we're going to do the same in the next column with integrating. The integral of cosine is sine. The integral of sine is negative cosine, and the integral of negative cosine is negative sine. On the right hand side, we're just going to keep track of signs. So we start with plus, minus, minus. And hold on a second, let me check the sign thing. Okay, actually my apologies, we need to not start with plus, we need to start with negative. So negative, positive, negative, positive. So we got to figure out some way to remember this, whatever you got to do to it. Okay, so what we're trying to evaluate is the integral of basically this guy times this guy, right? So the integral of x squared times cosine x with respect to x is going to equal, what we're going to do is we're going to go down and across. We're going to multiply down and across. So it's going to equal x squared times sine x times a positive number, right? So like if you want to write this, it's times a positive. You don't really need to do that. You just keep track of what it is. And then we're going to add that to, we're going to multiply the next one down and across. So it's going to be plus 2x times negative cosine x times a negative. Again, I'm just going to keep track of that for now. You could just be simplifying that as you go. And then we're going to multiply that by 2 times negative sine times a positive. So that's going to be plus 2 times negative sine and then there's a positive. Right, and so we can just simplify this, and we're going to get x squared sine x. Right, this one is we're going to have two negatives over here for the next term, right? Negative and negative, that's going to make it positive. So plus 2x cosine x. And then in the last one we have a single negative there, which is going to give us plus 2 sine x, and then just don't forget to add a c. And what you should notice is that this is the same as that. And maybe it's easier, maybe it's not, but it's a little more organized way to do it. All right, hopefully that helps.